Welcome to this topic. In this topic, we'll be looking at the atom. What makes an atom an atom? Alright, and we're going to be seeing at it where it belongs in the periodic table, as well as what effect is there with the number of protons, neutrons, or electrons. What is the atomic mass, as well as the atomic number, as well as its charge, and what makes an atom unstable. Okay, so I would want us to be seeing what element is it. When I start to add the protons, neutrons, or electrons, which one makes it the element particular? So let me put here element. I want to see the element. I want to see it in neutral or an ion also, and I want you to tell me if it's stable or unstable. So let's start with the first one. Let's consider adding on a proton. That atom would be the hydrogen atom. That's the first element in the periodic table. There you can see that there is one proton. Here we have one proton, one proton, or in other words, this is the atomic mass, this is the atomic number. This charge here is a positive charge, means that this atom has a charge of positive 1. Okay, so let's see what happens now if I was to add a neutron. If I add a neutron, the only number that changes is this top number. So let's see what happens now if I add another neutron. That number changes. It's unstable. So we can see that the more neutrons it have compared to its balance in protons, it becomes unstable. In other words, if we add another proton, will it make it unstable? Yes, it will make it unstable. So in other words, so long as the ratio is not even, then we have an unstable atom. So let's take off a proton so we can see in the simplest form our calculations. So we have been adding on protons and neutrons. We see that this number here at the bottom is the atomic number. This is known as the atomic number, or represents the number of protons. This number 2 represents the total mass of the atom, which is the number of protons plus the number of neutrons. Okay, so what about the electrons? If you notice here, it says ion. It has a positive charge of 1, so we have a positive charge of 1. So let me add an electron. Now note carefully, if you're using this type of simulation and I was to put it on the second shell, it will go to the first shell because it is made such a way. Okay, now the charge went to 0, the number 2 remains as 2, this one remains as 1. So adding on electrons or removing the electron will simply cause a change in the atom's charge. So adding an electron or taking away the electron just simply change the charges on the atom. The amount of protons and neutrons will make the atomic mass, and the number here will represent the atomic mass, and here we'll have the atomic number or number of protons. This big letter H here, it is not just an alphabet. This is the symbol for the atom. So let's see what then happens if I was to add another proton. Notice the number 3 increased here. This 3 came from the total number of protons plus the number of neutrons. I add one more neutron, becomes 4. The charge is now 2, positive charge of 2. It does not have any electrons. So let me add an electron here, and the charge went down to 1. Let me add an additional electron. Let me try to put it out here and see what happens. It finds its shell. In other words, it must fill its first shell before it can go to the second shell. Now if I was to come here and add another electron to this shell here, it can't, because this is already full. In other words, as you go along adding on electrons, you will know when the atom is already full on that particular shell. These rings out here are known as shells. And here we can see in what atom it is. It is a helium atom, by just changing the number of protons and neutrons. So what is it that we can see from here? we can see if the atom is neutral in charge, meaning then it has a zero charge, meaning then also the number of protons must equal the number of electrons. So adding an additional electron will cause the atom to have a negative charge. We had seen that so long as the number of electrons are less than the number of protons, it will have a positive charge. If the number of electrons are more than the number of protons, then we will have a negative charge. This number here is known as the atomic mass, and the atomic mass is equal to the number of protons plus the number of neutrons. Alright? And if the atom is stable, then that means that the number of protons must equal the number of electrons for it to be neutral or have a charge of zero or neutral in charge. That is simply for the atom. So the protons and the neutrons are also in the center, which is known as the nucleus. So we have the nucleus, we have the shells. The first shell will have 2 electrons. Let's see what that happens with another one. Let's change it to maybe here. Okay, to oxygen. So here we have 2 protons, so that will be 2, 3, 4, 5, 6, 7, 8. 8 protons. Let's put on 8 protons here. How do we know when we have reached to the 8 protons? We can look at the number here. It is very unstable. So we have reached 6 protons, 7, 8 protons. It is positive in charge because the number of protons is greater than the number of electrons. So let me make it more stable. Adding on the number of protons as well as the number of neutrons will make the atom stable. So it goes there, 16. So you have a stable atom now, but the charge is still positive. So let me add the other number of electrons. They start to find its shell, as you can see, where they belong. There we go. There we go. We have neutral in charge. So we have here 1, 2, 3, 4, 5, 6, 7, 8. The first shell will hold 2, as you can see, and then the second shell will then hold 8. We will have 2 more here. Let's see what then happens here. This is neutral in charge, this is negative in charge. So you can see, as up here you can see number of electrons, number of neutrons equal the number of protons. It has a negative charge because the number of electrons are more than the number of protons. So now it will have a neutral atom or zero charge. It is the atom oxygen. It has a total mass of 16 with an atomic number or number of protons of 8. So this is for the atom.